The hardness reading is stable at 62 HRC.
Good. Microstructure looks consistent as well. We can approve the batch.
There's a clear discontinuity right here on the B scan.
I see it. Let's isolate the frequency and check the depth.
The profile meets the specifications across the entire range.
Confirmed. The hardness levels are within tolerance.
We're good on gauge and alignment.
Confirmed. The wheel set is within specs.
The CPK index on the casting temperature is holding steady.
Yes, and the X-bar chart confirms minimal variation on the last 1,000 units.
Make sure the probe is flush with the surface to get an accurate reading on that crack.
The virtual model highlighted the exact same area.
As the simulation runs, we can monitor the thermal gradient during braking and analyze the stress points in real time.
Look at this data. The heat treatment significantly improved the fatigue resistance.
Yes, the microstructure is perfect. This will extend the wheel life substantially.
Wheels designed for heavy haul freight service with enhanced wear-resistant properties, allowing them to carry 30-ton axle loads across thousands of kilometers.
The new profile is pristine, while the worn wheel shows significant flange wear and a hollowed tread. When the wear
Make sure those straps are tight and we can't have any movement during transit.
Copy that, Supervisor.
The failure analysis suggests stress fracture 4B. I recommend the high-density composite wheel for replacement and increasing the maintenance cycle to 500 hours.
The cross-section reveals how the polyurethane and rubber layers compress to absorb shock, significantly reducing stress on the track.
Industry 4.0 relies on ubiquitous IoT sensors collecting real-time production data.
Our carbon footprint tracking shows a clear downward trend, thanks to our energy reduction and waste minimization efforts in manufacturing.
So the university's analysis confirms that this titanium composite drastically reduces wear, which is crucial for the high-speed corridor.
All parameters are within the UIC and AAR tolerances.
Confirmed. The scan is complete and compliant.
Always double-check the isolation points during the procedure.
And this digital checklist has really streamlined the process.
Lower it slowly, watch the alignment on the left side. Copy that, watching the clearance now.
Calibration sequence complete.
Torque is within tolerance. I'll log it as finished. The tolerance on this radius needs to be tighter for the new wheel design.
Let's adjust the feed rate on the 5-axis.
The specs are holding 0.001. All right, keep that grinder steady.
This flowchart for the new safety protocol looks solid.
By implementing this, we improve efficiency and reduce risks.
The data supports a rollout in Q3.
By upgrading to energy-efficient robotics and optimizing our processes, we've achieved significant material yield improvements and lowered manufacturing costs.
This roadmap outlines our strategic investments in automation and advanced materials, crucial for the next phase of digital manufacturing.
Now you try the sequence we just discussed.
Okay, applying the new parameters now.
Our employees logged thousands of volunteer hours this quarter alone.
It really shows how dedicated your facility is to the regional economy.
From our facility, these wheels are shipped across the globe, meeting the precise specifications of railways on 3 continents.
The quality and reliability of these wheels are unmatched. We also deeply appreciate the prompt technical support from the manufacturing team.
So the robotic integration streamlined the entire workflow.
Absolutely. And the simulated stress tests confirm the enhanced durability of the new alloy.
By optimizing the spoke geometry here, we reduce weight without compromising integrity.
And the new finish meets the customization specs.
Global market analysis indicates a sharp rise in demand for modernized railway wheels. Driven end-of-life wheels are collected, recycled, and the steel is reprocessed into new wheels, closing the material loop.
The lattice structure on this wheel reduces weight by almost 40%.
And the sintering process gives it the required strength for testing.
As you can see, the housing fits perfectly flush with the seal.
The tolerances here are remarkable. It's exactly what we designed for the high-speed application.
By integrating early with our bogie manufacturers, we ensure the wheels, axles, bearings, and suspension systems work as one optimized unit. The thermal gradient looks stable at the flange.
Agreed. Initiating the nitrogen flow now.
high-altitude railway wheels manufactured with materials and designs proven in low-temperature, low-oxygen environments of mountain railways.
The priority shipment to Cairo is still on schedule.
Yes, GPS tracking confirms arrival by 0800 Zulu.
Based on the load data, the Series 4 composite wheel should reduce your wear rate significantly on that western gradient.